Hi everyone. Well, here we go again. This topic for this video is graphs of using the graphs of functions to find the limits. And we will, before I start, I just want a couple of announcements. This video will be posted on Tuesday. You've got Wednesday and Thursday, and it's due Thursday at 11:59, the video and the bookwork. And that'll be page 758, numbers 34 through 40. Please submit both the notes and the bookwork in PowerSchool. I will provide a step-by-step attachment that'll help you do that. I was just trying to, well, I am not ignorant of what it looks like on your side anymore, so I did find out how it looks for you, and I set up a step-by-step method for you to get that done. Now, something that's new. And I said that I wouldn't be doing this, but then I was told that I need to do this. So I'm going to have to test you, and there'll be online tests. They'll be on PowerSchool. The test is going to open at midnight, and that'll be Friday morning. This is on the 17th. It's going to close at 11:59 p.m. on Friday. So there is a 24-hour period where this test will be open. You have to do it in that time frame. Now, you also have an hour and 15 minutes, and once you open the test, you have an hour and 15 minutes to complete it. You cannot just pause it and come back to it and still get that whole hour and 15 minutes. If you have to finish the test in an hour and 15 minutes. That is, everybody's getting extended time. That's more than enough time to take it, and it's time and a half from what would normally be given under any circumstances. So it is time enough for everybody to be able to take it. There are expectations, and that assignment and that video will be up, and there will be a pledge for you to sign and turn in on just the integrity of testing in this method. Okay, now to the topic. Using graphs of functions to find limits. Alright, here I go. It's example 1. It says find the limit of x plus 3 squared plus 2 as x approaches negative 3. So what I want to do is, we're saying we're using graphs. Let's just recall some of our skills we've developed this year in graphing and such. And I'm setting up some axes. And just to make the graphs. Now, I know that if I move this, it would go 3 units left and 2 units up. 1, 2, 3, 1, 2. That's the vertex. The vertex normally is at 0, 0 of y equals x squared. And then I think I go like over 1, up 1, and then I might go over another and up 3 from there. Somewhere around here. These points aren't that important. The vertex is important. The negative 3 value is important. And I think your graph looks something like that. Okay. Could have just plugged negative 1 in. Plus 3 is 2. 2 squared is 4. 4 and 2 is 6. 1, 2, 3, 4, 5. Okay, so I'd be right around there. And right around there. Okay. Alright, so I do have a decent looking parabola there. Now, the limit as x approaches negative 3. So from the right, I'm here at negative 1, negative 2, negative 3. Right there, I am at 2. As I approach from the left, from the right, yes, the left. you'll notice we come down from the left as we follow this curve, and when we get to -3, we are at 2. We're at the same spot. So the answer here is the limit as of x plus 3 squared plus 2 as x approaches -3 is 2. That is the answer. And that's how that one is done. All right. I've got 4 examples here. I may do the first 2 on one video and the last 2 on the second video. Now, example 2, it says find the following. Now this is a rational function that the limit as x approaches 4 of x squared minus 16. I'll write equals there. We'll write our answer here. But I want to simplify this. X squared minus 16 over x minus 4 is, if I factor x squared minus 16, I get x plus 4 times x minus 4, and put that over x minus 4. Those cancel, so this is equal to x plus 4. But we have a problem with our original function. X can't be 4. Because in the original, that makes the denominator 0. So let's just keep in mind there's a hole in this graph, if you remember having to deal with that at all. But basically it follows the graph y equals x plus 4 with one little exception. Now, and that exception being that x can't be 4. So if let me go right around 10 there and go 1, 2, 3, 4, 5, 6, 7. I know the y-intercept. I may not do much here on the negative part here, although I do know -4 would be where this hits the axis. And I know the y-intercept here is 4. And 1 plus 4 is 5, and 2 plus 4 is 6, 3 plus 4 is 7. 1, 2, 3, 4, 5, 6, 7. 4 plus 4 is 8, but you remember, I'm going to put an open circle there. 5 plus 4 is 9. That one's an okay to figure out. Okay one to figure out. So here's our graph, and I got that open circle here, because there's a hole in the graph. Alright, so as I come at 4 from the right, if I come down on the graph to 4, I am right here. I get right to that hole. It approaches this 8. Okay? This graph is at 4, 8. This hole, I mean, is at 4, 8. If I approach from the right, I'm approaching to that same point. The answer to this question is 8. Okay, I'm going to put the last 2 examples on the next video.